Today, I am gonna share to you about Steam system. Yeah. This is the big topic. Yeah. Maybe I need several presentation, several stage, steps. Maybe it takes 3 or 4 presentation in separate film, in separate videos that I will upload in this YouTube. Okay. Uh, no one in industry don't know about the Steam system. This is the one of the most utility system, the most popular of utility system that install in many application in industry. Most of industry use this Steam system. Yeah, maybe uh, almost 100%. Yeah, almost more than I think more than 90% of industry install Steam system, utilize Steam system. Um, why Steam system so popular? Because it is easy to maintain, and then also it is easy to uh, uh, in terms of steam, it is easy to control. You just control the pressure of steam, yeah, the pressure of steam, and then from them, you can also you can control the temperature, control other aspect, other parameters such as fuel flow rate, and also air combustion flow rate. And then why the second reason why steam system is very popular, because water and steam, in in shape of in at the pace of steam is one of the highest energy density to transfer energy heat, yeah, in heat from side to side, yeah, to transfer heat from side to side. This is the most effective media, because they have the steam have the high intensity of energy content. So in the past, when we talk about the steam system, when we talk about the steam, so we mention about the boiler. We just focus on the boiler itself. Yeah, it is based on my experience also. The first years, yeah, during my profession, during my journey to the energy efficiency, during my profession in energy efficiency, in the first time, I talk about or I focus on boiler system or boiler itself. Yeah, not talk about the system as a whole, not talk about the or not analyze the system as the steam as the system as a whole. Yeah. This is what I found, that this approach is not effective. Yeah, focus only on equipment, which is in this case is boiler. It is the ineffective way to, in term of the cost, in term of the optimization, because when we talk about the optimization, we have to talk as a steam from the generation up until the end use and the return to the boiler. We have to talk the whole system. We have to talk about the whole system. And when we take a look at this steam system, basically the steam system is consists of four parts here. We divided this into the 4 parts. The first one is initially it began with the steam generation, which is water changed to become vapor, to become steam here in the boiler. We talk about the steam generation here. And then the main equipment in this generation, steam generation, is boiler itself. Yeah? Boiler, maybe is the most expensive one in the steam system is the boiler itself. The tools or the equipment that convert steam to become vapor or water to become steam. And then the second one is the distribution system, which is the steam is distributed to the end user through the steam piping system. When we talk about the steam piping, we just not talk about the piping itself, but we have to talk about the insulation system also. We have to talk about the many types of the valve. Yeah. For example, valve reduction, pressure reduction valve, and we have to also to mention about the steam trap that installed in the line of the steam pipe. And then the third one, we also have to talk about end user, which is the equipment or the media or the equipment or the subsystem that use steam to many purposes. Including heating, convert steam to mechanical, such as in turbine as a driver, yeah? Turbine as a driver, or turbine as a generic electric generation. And then many others uses of steam in the end user. There are so many, but typically steam is using for the heating system, and then the second one to drive or to drive the equipment by the transform the steam to become mechanical energy. And then the third one is typically the steam is used for electric generation in turbine, in steam turbine and generator, electric generator. And then the third one, and then the fourth one, the last one, we have to talk also about the steam recovery. What I mean with this recovery is because after the steam is using, after using of steam in the end user, the steam we hope that this steam can recover 100%. We intend to recover the steam 100%, which means that all of steam that's in this state probably have convert to become condensate, to become liquid, hot liquid, after the using in the process or in user, the steam be convert or transformed to become the condensate. Mostly in the liquid phase, yeah, in the liquid phase. So we try to recover 100% of this condensate to flow back into the boiler, yeah, return to boiler. If we can utilize, or if we can return this steam, 100% of this steam, which is in the space in this state have become have convert or transformed to become condensate. So we can saving many aspects. The first one, we can saving the chemical contaminant, chemical matters that usually we use to treat the water. If we take the water from the raw water, yeah, the raw water from the well, water well, or from the water supplier, we have to treatment this water, which is in this state, we call this hard water, because it contains so many contaminants such as mineral that we prevent to enter the boiler, because this kind of mineral, they will not evaporate in this boiler, and as a result they will become contaminant in the boiler that we can plug or can trap the piping system. They can clog the piping system. They can clog the piping system with this mineral that not evaporate in this boiler. So we have to prevent mineral inside enter the boiler system. So we need the water treatment plant to treat the feed water boiler. This treatment including the chemical treatment, including chemical treatment. So we need to inject the chemical matters, the chemical substance into this treatment water treatment. But if we can recover 100% of the steam from the user to the boiler, we don't need to treat this water, because they already suitable for the boiler purpose. They already meet the boiler requirement. But sometimes, very often, we can recover most of the steam because this steam mixed with the product. Some of the process in industry mix the steam with the product. So this steam become dilute with or become contaminated, with the many substance that we don't need enter to boiler system, or the steam become dirt. So we cannot use this anymore. We cannot use anymore. So we have to waste this steam, or we should have to waste this condensate to the environment, or to the treatment system, or to the waste treatment system. So in this case, when we cannot recover 100% of steam, we have to add the feed water with the raw water. We have to add this feed water boiler with the raw water. So we need to treat first, in the water treatment, mostly with the chemical treatment, and this water enter to the boiler, and cyclus complete, and this process is gone. So we can conclude that the steam system consists of these four stages, 4 parts: steam generation, steam distribution, end user, steam is an end user, and the condensate recovery. If we talk about the generation, The component that mostly lies in the steam generation system is the first one is boilers. The second one is boiler auxiliaries. Here including forced draft fan, induced draft fans, which is extract the air from the environment to become the combustion air, and then the control system, etc. And then the third one is economizer. This equipment is one of the type of the heat recovery system. When the economizer you extract heat from the or transfer heat from the flue gas, we know that the boilers because in the boiler we combust the fuel with the air, so they will produce the flue gas or stack gas that we deliver or we throw through the chimney or to the stack. And then we know that the temperature, mostly the temperature of the flue gas is more than 200 degrees Celsius. Yeah? It depends on the pressure of the steam. It depends on the size of the boilers. Mostly this temperature could reach more than 200 degrees Celsius. But in many cases, in the big boiler or in the huge boiler, this temperature could high than more than 400 degrees Celsius. So we can recover this heat. Otherwise, we waste this heat into the environment. We can extract this heat. We can recover this heat to heat it, yeah, to heat or to increase the temperature of feed water boiler. So for example, if we have the feed water boiler 20 degrees Celsius, when they enter economizer, and after in the output of the economizer, they can reach temperature more than 100 degrees Celsius. But in many cases, they can reach the temperature of 230 degrees Celsius. And then the other ones is air preheaters. Air preheaters is utilize or recover heat to increase the temperature of air combustion. As we know that, as I mentioned before, that the boiler need air from environment to combust the fuel. So we need the air combustion, yeah, to mix with the fuel, so they can so the combustion can take place, yeah. But we can utilize this. We can increase the air temperatures, the air combustion from the environment when we enter the air preheaters, because air preheaters it is kind of it is similar with economizer. They recover heat from the flue gas, but in this case for air preheaters, the heat is used for increase the air combustion temperature. The other one is water treatment equipment. What I explained in before, yeah. And then the other one is deaerator. Deaerator is the equipment that we know that the waters, yeah, the feed water boiler consists of certain amount of oxygen, yeah, because this with feed water we take from the environment, so from the surrounding, from the well or from the storage, water storage. So this water contains a certain amount of oxygen, and then we have to prevent this oxygen enter the boiler, because the oxygen when they react with the ferrous, yeah, which is the that build the material of boilers. Boilers is built from the iron, which is the major element is ferrous. When ferrous or iron contact or react with the oxygen, it will take there will uh, electrochemical process take place there, which is the same. This is the corrosion process, electrochemical reaction or corrosion process, which is the ferrous and oxygen will react uh, and produce or and become the other substance, namely ferro or uh, ferroxide, ferrous oxide, ferrous oxide, which is we know that ferroxide is the product of the corrosion process, the product of corrosion process. The other one, steam generation, also equipped with feed water pumps, and then the last one they also equipped with fuel storage and handling equipment. If we combust this boiler with the solid equipment, yeah. Sorry, I have to close first. Hello.